All right, good morning, folks. We're going to jump right in here. And as he said, my name is J.R. Rickerson, and I run a small company called Red Rivet Studios, pretty much just me, and do freelance software development. I've also been an instructor for Python and several other technologies over the years. So I enjoy teaching and have a myriad of other hobbies. But one of those hobbies is games of all sorts, right? So we're going to talk today about games a little bit. And we are going to talk about a particular game, just kind of as an illustration of some of the features of Python we're going to talk about. So if we can come out of this talk with a little bit better of an understanding of some of these Python features, and I don't clock myself on this screen or anything like that, I think we'll consider that a success, right? So the features, what we're going to be talking about, as you probably saw in the title, are iterators and generators. And I'm just going to use the games kind of to demonstrate some of the things that you can do with iterators and generators. If you've never used iterators or generators in Python, or maybe you didn't realize you used them, that's okay. This is intended to be very much introductory material. And if you've been using Python for years and years, you might learn something new as well, right? Sometimes we don't always peek under the hood at the way some of these things work. So we're going to go over some iterator and generator concepts. I'll show you some code snippets, and then at the end we will hopefully have some time to demonstrate a little version of a game and compare how you might implement that sort of in the classic Python way, you know, just the looping approach versus using something like generators. All right, so before we get started, this talk will not have anything about AI in it, and no AI-generated images or anything like that. So if you're in the wrong classroom, you can feel free to step out to an AI talk. All right, so let's learn about the game that I'm going to be talking about, Snakes and Ladders, and you'll see in the next slide, some of you may know it by other names, right? And one of the things I like about games from my hobby is that a lot of games have a lot of history, right? People have been playing games for like a really, really long time, and you'll find them in every sort of culture, right? So Snakes and Ladders that you may have heard of comes from India in the 2nd century. There was a whole family of games, but this one is called Gyan Chapur, and I'm sorry if I butchered that. My Hindi pronunciation's not so great. But it did get adapted by the English in Victorian England when they brought it back from India. And the game was very, very basic, right? So you have this grid of 100 squares, and it doesn't really have a strategy to it. You're basically rolling dice or using some kind of a spinner or something like that. And it was primarily used to teach people like morality lessons, right? So if you look at this board, and this is from a museum in India, it has, you can see the snakes on it. I don't know if I can do the cursor here. The photo is kind of small, but the snakes are like vices, right? So they were teaching these moral lessons that if you get involved in, you know, drinking or gambling or some other vice, it was going to slide you down back to a lower sort of position in life. And then, you know, if you could avoid those things and make it all the way to the top, right, then that was like a better approach to your life kind of thing. So some of you may recognize this version of it. After, you know, it became sort of popular in Victorian England, we adapted it here. Milton Bradley specifically released this in 1943, right? This is Chutes and Ladders, which I grew up with, and maybe some of you did as well, right? And we kind of kept the same morality theme for a while. If you had a version from the 80s or 90s or something, it might have been a little bit toned down. But if you look at this board, right, a lot of this stuff is like lessons for children. You can, you know, clean up your room, or you read a book or something like that, and it gets you something good, right? It shows children getting rewards. It shows children graduating from school and that sort of thing. So they kind of kept, you know, that general same theme, right? But it's a very basic game, and it has this very old history. And so we're going to use this to kind of explain the iterator and generator concept and make a few comparisons here to hopefully help us remember it. Okay, so as I mentioned, the way you play this game, it's at least the Chutes and Ladders version now is on a 10 by 10 grid, right? So you're just trying to get from 1 to 100. That's it. And it's basically a race. You roll your dice or you flip your spinner and it gets you however many spaces ahead, right? If you land on a ladder, you move up the ladder to a higher space, right? Pretty simple. And if you land on a snake or a chute, you slide back down to a lower space, right? So there's really no strategy, it's just luck. You're just spinning the dice or the spinner, as you can kind of see right here. So I kind of like to make a comparison here to these iterators and generators that we're talking about, right? So iterators, to me at least, are kind of like the ladders, right? So we'll compare the iterators to the ladders and the generators to the snakes. And maybe it's not the best metaphor in the world, but maybe it will help you remember a little bit about how these things work, right? So let's look at a little bit more technical stuff. All right, so iterators, just like the Chutes and Ladders, Snakes and Ladders game, have been around for quite a while, and in Python time, this is quite ancient, I suppose. So this goes back to Python 2.1, right? You can find the introduction of iterators in their sort of current state, right? The current protocol of iterators in PEP 234, right? So this dates back to 2001. This is reasonably early Python. You know, Python was created in the early 90s, so this wasn't too far into it. And when we talk about protocols in Python, right, there's a lot of kind of hype going around lately about Python typing and type hinting and enforcing types and that sort of thing, right? And that's great. I think it's a good progress, but some of the things in Python are not built on hard typing, right? They're built on these concepts called protocols, where we can say we don't really care what the object is. We don't care what the type of it is. As long as it supports certain methods, we can do stuff with it, right? You've probably heard the term duck typing when talking about Python. And that's kind of how this stuff works a little bit. So we're going to talk about what the iterator protocol is. We're going to see it in action a little bit here. And then at the end, like I said, I will hopefully demonstrate a little game I've written using these things. All right, so what is the iterator protocol? Basically, we just need an object that we can call next on, right? There's a built-in function in Python called next that asks the iterator for the next item, right? And I kind of compared it to the ladder here because a ladder, if you think about a ladder, what makes it a ladder, right? It's those rungs. Otherwise, it's just a pair of sticks, right? So the rungs are like your next, right? All I care about on the ladder is going up to the next thing. I don't usually consider the whole ladder at once when I'm climbing a ladder or using a ladder, right? So each time I call next, the iterator is just going to give me back the next item, right? And we don't really care. We'll see some of the advantages of this. We don't really care how we get that item. We just get that item back. So here's an example of an iterator using an iterator in Python, right? So you've probably done something like this. If you've touched Python at all, you've probably come across for loops. And maybe you didn't realize those were iterators, right? Maybe you didn't know the terminology yet, but if you've used a for loop, you've used an iterator in Python. Excuse me. So what we're doing here in this example, and hopefully that's clear enough for everybody, we've just created a simple Python list, right? This is just a list of games, right? Just strings. And we want to go through that list and get each item, and we're just going to print it out, right? So when you do this for loop down here, when you say for game in games, we are asking the games list for an iterator. Give us back an iterator, please. And then every time we go through the loop, we call next. But all of this stuff is hidden from you. You don't usually have to worry about calling next yourself. That's what the for loop is doing for us, right? So each time through the loop, we say next, 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 until we get to the end of the list, and we will stop going through the list because the list will actually, or the iterator, will actually raise an exception. You don't see that exception, it kind of gets caught behind the scenes, but it's a stop iteration exception, right? And that's how Python knows how to stop at the end of the list. So all of this stuff, because Python is kind of a cool language that's very like simple and easy to read, it all gets hidden away from us. But it is kind of nice to know what's under the hood a little bit and get a better understanding of this, because it turns out that Python is also really flexible in that we can create our own versions of these things. And I'll show you a little bit of that in just a moment as well. Another place you may have come across iterators, maybe not realizing it, is if you ever read from files, right? So files also can give us iterators, and this is a very simple example here of opening a text file, and the bottom box there might be the contents of that text file, right? So this might be like a list of numbers, it could be names, it could be whatever. So when we open the file and we get that object called file, that variable that I've got there, and then we do for line in file, yes, it's another for loop, but it means that we are getting that iterator from that file instead of from a list, right? That when I open that file, it's not a list, it's a file object, right? But because it supports that same iterator protocol, we can ask it for an iterator and we can call next on it, next, next, next. And every time we call next, we are getting the next line of the file, right? So once again, you see the for loop looks almost identical, right? If I go back, it's pretty much the same for loop. I don't have to care, as the person who is asking for things from the iterator, whether I'm getting that data from a file or whether I'm getting it from a list or a dictionary or what have you, right? All the built-in sequences in Python support iterators automatically for you, right? I can iterate over dictionaries, I can iterate over tuples, sets, whatever, right? And they work exactly the same way. So let's look at how they actually work, and let's talk about magic methods. Has anybody heard the term magic methods before? Yeah, a few of us, right? So when we're talking about Python protocols, right, we're talking about iterators, we're talking about all sorts of other things that you can do in Python. There are all these sort of hidden methods behind the scenes that sometimes are called magic methods. And these things are how Python operates, but it also means it's how you can create something that operates in exactly the same way yourself, right? So if I want to be able to create my own type that I can loop over with a for loop the same exact way that Python loops over things like lists and files, I can do that because of these magic methods, right? So the first one involved in iterators here is the iter function, an iter method, right? So there's a built-in function called iter, right? If you just look up built-in functions in Python, you'll find it. And all that function does is asks an object to give me back an iterator, right? Something that I can then call next on. So this is what the for loop is doing behind the scenes for you. It is calling this function iter to get back an iterator, right? And if you want to support iterators with your own types, as I'll show you here in a moment, you can you can support that by implementing that _iter magic method, right? So most of the magic methods you'll hear about in Python all start and end with the _ that you see up there. It's kind of hard to tell that it's a _, right? But if it has a _ iter method on it, then you can call that iter function and get an iterator back. And that's the only way that Python really knows whether something is iterable. Has anybody tried to iterate over a for loop over something that's not iterable before, right? You'll get an exception. And it's because when Python sees you doing a for loop, Python calls iter on that type, and if there is no _ iter, it says, hey, I can't do that, right? You usually get a type error, right? So this is how Python knows what is iterable. I know that's kind of a weird word, but that's what we call things that you can iterate are iterable types. Okay, so if you support the iter method, you can iterate over your type. The other magic method that we have here is the next, right? I already mentioned the built-in next gives us each item in the list here. And if you support _next on your type, then your type is an iterator, right? It's because you can now call next on it and get an item. What does it mean, get an item? That's up to you, right? So if it's a list, it might be, here's the next thing in the list. If it's a file, let me read the next line of the file. If it's a network socket, let me pull down the next set of requests or responses or whatever. And the next method is where this stop iteration exception happens. So just to reiterate, the magic methods are cool because I don't have to know or care about the details of the type, right? After I've built the type, anybody can use my type and they don't have to know how it works internally. All they have to know is I can call next on it. Okay, so how do we make our own iterable class, right? Well, the first thing you do is you start with a class. It doesn't have to be special. You don't have to inherit from any particular object or anything like that. You just create a regular old Python class and you implement the iter method. Now, what's kind of cool about that, let me see if I have this snippet here, is it can be something like this, right? Where we just return our self. I can create a type that returns self if that type is also an iterator, right? So that's all I'm doing is returning the same thing that my class already is. All right? And then the next step is, of course, you implement next, right? And I've done that in this quick sample. And by the way, I'm going to have all these code samples and everything up on GitHub a little bit later today, so you'll be able to find that, right? In this case, I have a list of names that is part of this type, and the only thing that I need to do in order to support next here is I just pull out the next item here out of the list, and I'm remembering what position I was at, and I return it, right? So now I've created my own iterable class that can iterate over a list of chess pieces. Okay, so let's move on to talking about the snakes, right? Generators, we're going to compare to snakes here. And I do that because, you know, it kind of sprung to mind when I was thinking about doing this talk, this particular image of the snake eating its own tail. You've probably seen this in mythology and so forth. And we'll find out one of the things that you can do with generators kind of reminded me of this snake symbol. So that's kind of why I put this together. But generators were added in Python 2.2, right? PEP 255, right? So these came pretty shortly after iterators. And they introduced a new keyword. If you've ever seen the yield keyword, you've probably dealt with generators a little bit. These also work their way into a lot of the async stuff, if you've ever worked with asynchronous Python. But we're not going to get too far into that stuff. So generators require iterators. Generators are iterators, but they have some extra magic. They kind of remember their context here. And you can do some cool stuff with them, like creating infinite generators, which is what makes me think of this snake eating its own tail. All right, so why do we care? Why are we talking about generators at all? What do they do for us, right? Well, a generator has this one little advantage over your traditional sequences, right? So normally when we think of sequences like lists and dictionaries and all that sort of thing, all of that stuff has to be loaded up front, right? And if we're talking about a little game with 100 squares or something like that, you know, maybe that's not a big deal. But you're talking about data science routines that are running through millions and millions of records or millions and millions of lines of a file or something, then it becomes kind of cost prohibitive to load all of that up front, right? Especially if we aren't really sure if we're going to use all of it, right? If I have to load, a several gigabyte file or something like that and try to fit it all into memory, and then I'm going to use like 3 records out of it because some condition causes me to quit out early or something, well, that's a waste, right? I've wasted all that time in memory in order to load that stuff that I don't actually use, right? So generators allow us to instead load one thing at a time from these sorts of sequences, right? So I don't have to care about the whole file or the whole list. I just want the generator to give me one item at a time without loading everything all at once. And as I mentioned a moment ago, something else you can do with generators is you can kind of create infinite sequences, right? So they're not really infinite, of course. Your computer will break down before that. But you can simulate having a list that doesn't really have any end, right? Okay, so usually when we see generators, and there's a variety of different ways that you can use generators here, they look like normal functions, right? They typically are designed the exact same way. And actually, if you go back and look at the PEP, that was under debate a little bit, right? There was some discussion around that PEP back in 2002 as to whether they should have a different def keyword, right? Define for generators instead of normal functions. But they decided against that. So the only thing that's different is generator functions will have a yield in them, right? That yield keyword makes it a generator. And those functions, they remember their context. So when you call a generator and you call next on it, it remembers the variable values and things like that that are inside that function. It doesn't go away like a normal function does. It doesn't reset, right, every time you call next on that generator. So here's an example of something similar to what I showed you in the iterators, but with a generator, right? And notice in this particular case, I don't actually have to create a list at all, right? With the iterator, I had a list and I could return item, 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 that sort of thing. In this case, I just have individual variables. And now I'm not saying like this is the most efficient way to write this code. Obviously, it's a bit redundant, right? But there is no sequence here, right? This is just the generator function, and every time you call next on this generator, you get the next value, right? Every time you hit one of these yield statements, the function pauses essentially where it is, gives you back the value from that yield statement, and then just sits there until you call next again. So the next time you call next, or the for loop calls next for you, it resumes exactly where it left off, right? So a generator has this special ability, unlike an iterator, to pause itself and kind of sit off to the side until you're ready for the next item. Okay, there are also enhanced generators. They added a couple of additional bits of functionality to generators in Python 2.5. And one of the cool things you can do with the enhanced generators is you can use this send method, right? So generators can have parameters just like any other function, but once you call a generator normally with those parameters, it remembers those parameters and they don't change, right, for the life of the generator. However, with the enhanced generators, if you use the send method, you can send new values into the generator, right? And I have an example of that in my game code, but we may not have time to look at that. Okay, so just to kind of compare generator functions here to a normal function, right? This is 2 examples of functions that basically do the same thing, right? One of them just returns us a list, and one of them is a generator instead. And the interesting thing about that is it doesn't matter what the client code is here. Like you can just drop one of these functions in for the other one without changing your for loop. You don't have to do anything special to use this generator, right? So oftentimes, if you are going to have some kind of function that is going to build and return a list or dictionary or set or whatever, you can just plop in a generator to replace that without changing anything else, right? So, all right, you can also create generator classes, right? So here's an example of that. You just need to support that iter method again, but we don't need a next here because our iter method is actually returning a generator, right? You see that yield statement in there makes that a generator. And then you can just call next on that generator. So in this case, by using this generator here, you see I don't have to have a list of like all 52 cards from the deck. I just generate each one as you go from this generator function. Okay, so I think we probably will not have time to go over the Snakes and Ladders game, but I will have the source code up on GitHub, and certainly you can feel free to talk to me outside in the hallway. But I'll just mention how I went about it really quick, and then we'll wrap up, right? So there's a couple things I looked at when building the game. The first was how you do player turns, right? Normally you would just say, I'm going to do a while loop. If it's player 1's turn, do this. If it's player 2's turn, do this. But instead, I could use a generator to just generate player 1, player 2, player 1, player 2, player 1, player 2 forever, right? With the dice, it's not terribly different, right? Because I'm still going to use the random module, but I can have a generator that just returns the next roll of the dice. And then the last thing that's a little different is the board here, right? Normally you think like I'm going to make a 100-element list. I have to remember where each player is on the list and that sort of thing. And I've actually put together a little generator that does that for me per player. Because the generator can remember its context, I don't have to separately keep track of where each player is because that's what the generator is doing for me, right? So we can look at that code out in the hallway or up on GitHub, as I mentioned. So here is my link to GitHub and some other ways you could contact me if you want to snap a photo of that. So, and that's it for my talk. So if you have any questions, I'll be out in the hallway just as soon as I pack up and get out of the way for the next speaker.